What's up, team? Today we're going to find the area of composite figures. My target below says I can find the area of composite figures. Hey, my mic's being funny. Sorry if the audio is weird. That's just what's happening right now. So I apologize. Hopefully you can put up with it for a little bit. Friendly reminder, area of rectangle, area of parallelograms. Area of a rectangle is base times height. So if you have the base, you have the height, multiply them together. This one happens to have an area of 24 units squared. Friendly reminder here, across the bottom we have 6 equal units. That's how we got the 6. We have 4 equal units up the side. That's how we got the 4. A square unit is just like it sounds. It's a square where each side has a length of 1. So we took this 1 by 1 little square here, and that's 1 square unit. So us saying that this thing has 24 square units means we have 24 of these squares that will fill up our entire figure. So same is true if you have square feet, square miles, square meters, whatever the case may be. That's what we're saying. Okay, parallelogram. Again, base times height looks really similar, but it's a little bit different. The height of a parallelogram is, well, I like to think of it kind of like it's a building. So the bottom side here is on the ground, the top side here is like the ceiling or the roof. And we are talking about how tall this thing is. So you would go from the ground to measure to the highest height of the building, creating a right angle with the ground, of course. So that's what this is here. If the building is leaning to the side, you're not going to measure it up one of the walls because that doesn't tell you how tall the building is. That just tells you how long that particular wall is. We want to know the distance from the ground to its highest point. In this case, it's 8. So when we do our base times height, we do 10 times 8 and at 80 square units. So this should all be a refresher from really like middle school math when you did some areas. Okay, here's our example. We're going to do just one here. So let's find the area and perimeter of this composite figure. A composite figure is just a mashup of multiple shapes that we're familiar with. So for this one, you can see a rectangle here. If we throw this dashed line, it's easier to see the rectangle here, the parallelogram here. So to find the perimeter, we're just going to add up all the side lengths. It's like a fence surrounding a field. We're going to measure the length of the fence. That's going to tell us our perimeter. And then the area, we're going to do something a little bit different. I'll show you what that looks like in a minute. So let's fill in the rest of these side lengths here that we know. We have all the information we need, even if it's not all showing right now. So this side up here, I'm noticing, has to have the same side length as its opposite of the parallelogram, which is the same as this one down here on the other side of the rectangle. So up here, we have an 11-foot side. Over here, this side must be 8 feet, and across the other side of the rectangle, this one must be 6 feet. This measurement over here, this 6.5, is not going to be relevant for our perimeter. But we'll see how it's used here in a moment. Okay, so perimeter. This is just where we add up all of the sides. So we have 11 plus 6, that's 17, plus 8. 17 plus 8 is 26. This puts us at 37. This puts us at 37.45, so 51, I believe. Correct, 51 feet. So it's 12, 16, let's see, 12 plus 16 plus 22. No, this looks like just 50. Am I mistaken there? There we go. 10, 20, 30, 40, 50. Yep, 50 feet, not 51 feet. Just adding up all the sides. Okay, moving forward now, finding the area. What we're going to do to find the area is we're going to separate our two shapes that we're familiar with. We're going to use our two formulas that we started out with. Find the area of the top one, find the area of the bottom one, and just smash them together and add the results. So we can fill in what we know up here with the parallelogram. Again, we have an 11-foot base, we have an 8-foot side, and then our height is listed out to the side, which is a little awkward, but really it's the same distance as this thing on the inside. So it's just like what we have down there, but we're going to say that our height, area equals base times height. So it's going to be 11 times 6.5. So the area of this top parallelogram here is 11 times 6.5. So what is that? That's 66 plus 5.5, which is half of 11. So it looks like 71.5 feet squared. Rectangle time. We know we have a base of 11 feet. We know we have a height of 6 feet. So this one's a little bit easier. Again, base times height. And the area equals 11 times 6, which is 66 feet squared. We have the area of the top chunk. We have the area of the bottom chunk. Let's add this business together. So it's just 71.5 plus 66. So it's 130, 137.5. feet squared. So our area in this case, 137.5 square feet. Boom, we're done. For your practice problems today, you're gonna have some stuff that looks like this, some stuff that looks like this, some stuff that looks like this. But also, you might not have a rectangle in parallelogram. You might have something that's like, I don't know, 2 rectangles, something like this, where you find the area of, in this case, part A and part B, and add them together. Same thing. Just maybe you have multiple of the same shape versus having 2 separate shapes. That's fine. You can still pull it apart, find the area, and smash them back together. Okay. Check out the practice problems. Let me know if you have any questions. You got this.